In order to understand and make use of a histogram, it helps to know how they are created. Frequency histograms are commonly used and easy to build and understand from an appropriate set of data. Density histograms, which use percentages for heights of the bars, are a bit tricky, but they are very useful when it comes to understanding how pieces of data are spread out. In this tutorial, we're going to address both frequency and density histograms. But for right now, we're going to go over the few mathematical skills you'll need to know in order to turn an appropriate data set or a frequency histogram into a density histogram. Does the mentioning of mathematical skills make you worried? Don't get too uptight about it. In a nutshell, the only skills you're going to need are addition, multiplication, and division. And you'll do each of those skills using a calculator. Even then, here's a quick explanation of how you're going to be using those skills before we actually show you how to do it. Addition. You're going to need to be able to sum up the numbers in a column and find a total, like 3 plus 4 plus 6 plus 2 plus 7 equals 22. Multiplication. You're going to need to be able to multiply a number that is in decimal form and turn it into an appropriate percentage, like turning 0.095 into 9.5% or 0.3758 into 37.58%. which is done by multiplying the number by 100 to move the decimal 2 places to the right on each of these numbers. Division. You're going to need to divide a smaller number by a bigger number and write the results as a decimal, like 23 divided by 197 equals 0.1168. And you're going to need to divide a percentage into a smaller percentage, like 13% divided by 20 equals 0.65%. In order for your results to match those in the tutorial, you'll need to round your answers to 3 or 4 decimal places, but no more than that. You'll be close enough to identify matching results to those you find without too much stress over rounding. A little addition, a little multiplication, and a bit of division using a calculator. Doesn't sound too hard, does it? We'll take a single data set and walk you through the whole process, explaining each piece a bit more thoroughly as we go, and before you'll know it, you'll have the skills down well enough to do it on your own. So if you don't have one yet, grab a calculator and let's move on to a data set. Let's take a look at the following data set. This table comes from a local hair salon and beauty supplies shop, and it divides up the shop's clients by the number of times they come in for a haircut each year. We'll go into the process of building and drawing the histogram in the next section. For now, we're just going to cover how to use those 3 mathematical processes to label the tops of each bar in a density histogram. So, look at how this frequency histogram has been put together, and see if you can figure out how the sets of numbers in the columns of the table get used in the histogram. Do you see where the categories go? Those are the intervals in the haircuts per year column of the table of data, and we use those to label the horizontal axis of our histogram. Do you see how the frequencies of the number of clients column is used? They determine how tall each bar is. We'll be calling it the bar height, and we label the top of each bar with the corresponding frequency from the table. Now to the heart of it. To turn a frequency histogram into density histogram, we need to refigure all the bar heights above the frequencies used in the table into percentages. But the percentages we use won't just be percentages of the total number of clients. We'll find those percentages, but we won't stop there. What we're going to do is find how much percentage each bar has per unit of measure across the bottom axis. In other words, we're going to find how much of the total percentage there is per haircut per year. This means that the bar heights for our density histogram will be labeled with the percentage carried by each individual haircut value along the bottom axis. If you don't get that concept quite yet, that's okay. We'll explain it better later. For now, let's just get the math down. Step number 1. Sum up the frequencies. In order to represent the haircuts data set in a density histogram, we have to first represent the height of each bar as a percentage of the total. That total is where the addition step comes in. We start by taking the heights of each bar and adding them all up. Do it with your calculator now and make sure you get the same sum that we have. 14 plus 26 plus 44 plus 84 plus 102 plus 98 plus 146 plus 48 equals 562. Step number 2. Divide to find and write percentages. Now that we know the total number of clients at the hairstyle shop, we can find a percentage for each category. This is where the first division step comes in, and where the multiplication does too. We're going to take each bar height and divide it by the total we found for the hairstyle shop's clients. Use your calculator and make sure you get the same decimals we have for all of them. And now let's follow up that step by multiplying each decimal by 100 to turn it into a percentage. This will move the decimal over 2 spaces to the right. Check what you find on your calculator against our answers. Step number 3. Divide a percentage to find a new percentage. We're at the last bit of arithmetic, and while it's the trickiest, it's not too difficult. We now have the percentages right for each bar on our histogram, but those percentages are not the heights we need for a density histogram. To figure the heights for each bar, we need to think back to a bit of algebra we all learned a long time ago. Do you remember how to find the area of a rectangle? The formula had many different versions, but they all said basically the same thing. The area of a rectangle is equal to the rectangle's base times the rectangle's height. This is often abbreviated as A equals B times H. Well, here's the kicker. Those percentages we just found in the previous step are the areas for each of the rectangular bars on our histogram, and we can find the base of those rectangles by looking at how long the intervals are on the bottom axis of the histogram. In this case, those bases are all 2, which we can find by taking the larger right-hand label of any interval and subtracting the smaller left-hand label of the same interval. So the base of each rectangle is 2 minus 0 equals 2, or 4 minus 2 equals 2, and so on. Take a second look at the data set in the table above and in the 2 histograms we've done, and see where to find this base length. So in that area formula we just looked at, A equals B times H, we currently have both the A and the B for each rectangle. But what we're after here is the H, or the height of each rectangle. If you remember solving all of those algebra equations in school, we can find H by undoing the B times H step to get the H by itself. In other words, how do I undo times by B? The answer is divide both sides by B. This means that we can take the area of each rectangle, which we found in the last step, and divide it by the length of the base, and we'll have the height of the rectangle. A divided by B equals H. For the first rectangle on the left, this would look like this. 2.49% divided by 2 equals 1.245%, and that's the height of the first rectangle. The second bar's height would be 4.63% divided by 2 equals 2.315%. So take a minute with your calculator and solve all of those area formulas for the rest of the rectangular bars on our histogram, and check your answers against what we have here. That's it! If you got all those, the mathematics is done. Now all that we have left to do to finish this density histogram is to put our new labels on the bars and on the vertical axis. Then we're all finished, but we'll cover that in the next section. For now, let's look at what the mathematics gave us. Why did we do all those mathematical steps? It's all in how a density histogram is meant to be read. Let's label the axis for starters and see if we can figure it out right there. Here's the labeled density histogram for our data. Look at what the new label is for the vertical axis. The information provided here is a bit different from a frequency histogram. The density histogram of this data tells us what percentage of clients per individual number of haircut was found in each category. For instance, by looking at this histogram, we can tell that about 9.08% of all haircuts in the year were for clients getting exactly 9 haircuts, and another 9.08% were for clients getting exactly 10 haircuts. If we wanted to find the percentage of clients getting between exactly 5 and exactly 13 haircuts each year, we would add 3.92% for 5 haircuts, plus 7.48% for 6 haircuts, plus another 7.48 for 7 haircuts, and continuing the same process through 13. The quick numerical calculation would be 1 times 3.92% plus 2 times 7.48% plus 2 times 9.08% plus 2 times 8.72% plus 1 times 12.99% equaling 67.47%. Each one of these terms is just the number of base units times the height of the bars in question. This is why, in the numerical calculation, the first and last terms are only multiplied by 1 instead of 2. We wanted to know the percentage of clients who got between 5 and 13 haircuts per year, and getting 5 haircuts puts a client halfway across the third bar on our graph, and getting 13 puts a client in the first half of the tallest bar on our graph. So we only count half of each of those bars, which is 1, instead of the full width, which is 2. Okay, that's quite a mouthful, but all we're really after here is getting down those 3 little mathematical skills so you can build one of these density histograms. Let's try a bit of practice first, and then we'll compare your histogram to ours. And if you're satisfied with how you did, we'll move on and see how well you can perform these skills on your own. Here's a new data set broken into ordinal categories and intervals. The data is taken from the NFL 2011-2012 season and shows the number of quarterbacks divided up in categories by their average yards passing in a game. We're going to give you a partial frequency histogram for the data set, and it will be up to you to use your newfound math skills to refigure the heights of the bars to be a density histogram. You'll do this by first finding the frequency total, then finding the percentage of each histogram bar by dividing each frequency by the total, and then turning each decimal into a percentage, and dividing those percentages by the width of the category intervals to find the height of each bar. Here's the blank frequency histogram. You can use the vertical axis tick marks if you need them to start the refiguring process. Once you have the new density histogram labels for each bar height, check them against our example. Let's check things over and make sure you understood how to do it. If you didn't label the percentage per yard at the top of the vertical axis, don't worry about it. We'll go into that better in the next section. Similarly, if you didn't label the vertical axis with tick marks, every 0.2 percentage points like we did, that's okay too for now. All we're concerned with here are the heights of the bars, so let's check the important pieces of those calculations and see if you got them right. Base length and category widths. By taking any one of these rectangles, we can find the width by subtracting the left-hand boundary from the right-hand boundary. 175 minus 150 equals 25, or 200 minus 175 is 25. So the base length for the rectangle bars is 25. Bar heights. All of these were figured using the 3-step process we went over earlier in this tutorial. We started by adding up all the quarterbacks in the categories and finding the total to be 33. We next took each category's quarterback frequency and divided it by the total. So 1 divided by 33 is 0.0303, and so on. Next, we turned these into percentages using multiplication. Finally, we divided these percentages by the width of the category intervals, or the base length as we called them previously. So 3.03% divided by 25 is 0.12%, and so on. So, how did you do? If you were off on the base lengths or bar heights, you probably should go through it again with this practice data set before you go on and try it on a new set of data in the assessment. If you got things right, you're ready to move on and try your hand at the assessment